Okay, Chapter 8, our main focus at the beginning is going to be talking about something called monomials, so we need to understand what that is. A monomial can be one of three things, basically. It can be a number all by itself, can be a variable all by itself, or it can be some product of numbers and variables. Basically, a multiplication of numbers and variables together. Those are your options. Something that will cause it not to be a monomial, one thing I'm going to mention at least, is if you are dividing by a variable. It's not going to be a monomial. There's nothing wrong with it, but it doesn't meet our definition of one. We are allowed to divide by numbers because basically if you're dividing by 2 or something like that, that could just be written as a fraction. So it could say we're multiplying by a fraction instead of dividing by a number. We've been using the word constant all year long, which is a monomial that is a real number. We refer to it mostly kind of simple terms as a number with no variable attached. The first thing I'm going to ask you guys to be able to do is to figure out just yes or no, is an expression a monomial just by looking at it. You don't have to do anything with them, but you should be able to tell me yes or no. So if you were looking at the expression w just by itself, does it meet the definition? Well, w is a variable, so yes, it is a monomial. Problem 2, is negative 3 a monomial? Well, yes, it is a number all by itself, so it kind of fits that description. And the third option I'm showing you real quick, negative 3 times w, or you might just read it negative 3w. That multiplication is a product of the number negative 3 and the variable w, so yes, it meets the description. Three quick ones there, and trust me, there will be ones below here that will not meet the definition and we'll have to say no on them. So if you're looking at example 4, it has 8 divided by y. I mentioned above we're not allowed to divide by a variable. It's not considered a monomial. So you're going to say no, and on homework problems, I'm going to ask you to explain when you tell me no. So your explanation might be, real quick, we are dividing by a variable. Won't make you write a full sentence or anything like that. Dividing by a variable, we're going to say no, it's not a monomial. We are allowed to divide by numbers. This could be written as 1/8 times the variable y. It could be written as a product of a number and a variable. So no problem on number 5. It does meet our description. We're going to say yes on it. Product means if you're going to deal with numbers and variables, they have to be being multiplied times each other. So on number 6, they're being subtracted here. So we're going to say no. And your explanation can be simply because we have a subtraction sign. Wx is one way to say it is w times x. It is a product of variables. Being two variables being multiplied, it meets our definition. This can be said as 4 times x times y times z. So one big long multiplication, 4 pieces involved in it. One big long multiplication, one long product. We're going to say yes. So far, those two things you've seen, dividing by a variable or a subtraction separating two monomials. The x by itself is a monomial. The 1 by itself is a monomial, but there's a subtraction sign separating them. It's not together a monomial. Have to scroll down. See what we got below here. Subtraction's similar to the addition. Number 9, because of an addition, you'll have to say no. Because of an addition sign. Hopefully that cleans my writing up so we can all read it. If you were looking at number 10, it's just the number 2/5 times the variable v times the variable w times x times y times z. This is just one big long multiplication, which is really what a monomial is. It's just one number by itself. It's the number negative 3/5. So it is a monomial. Problem number 12. This is 8 times y to the 4th power. You might think, well, I haven't mentioned exponents. Let's just remember what an exponent is. Exponent is just a way of showing repeated multiplications. That could be 8 times y times y times y times y. Basically, it's 4y's being multiplied, and we just wrote it in the compact form. So if you think of it as that way, it is just one big long multiplication. Thus, together, 8y to the fourth is a monomial. You're going to have to say yes on that problem. You see below on number 13, it's really just numbers. It's 2 to the fifth power. If you have 2 to the fifth power, once again, kind of using in what your knowledge of exponents, that's just 2 times 2 times 2 times 2. It's just 5 2's listed out as a multiplication. So, remember what we're doing here. We're saying, is it a monomial, yes or no? 2 to the fifth power is a monomial. More specifically, 2 to the fifth power could be written as the number 32 if you actually multiply those out. 2 times 2 is 4, times 2 is 8, times 2 again gets you to 16, and a fifth 2 in there gets you the number 32. So 2 to the fifth is 32. But for right now, all we're talking about, monomial, yes or no. Because this can be listed out similar to above, 2 squared, and I'm going to multiply that by 2 to the third, because it can be written as one large multiplication, you're going to say yes, it in fact is a monomial, and you might notice that 2 squared times 2 to the third, I listed out 5 2, so an easier way to write that would have just originally been saying 2 to the fifth, exactly like problem number 13 started out as. And that kind of will lead me into what we're going to look at below here, something called product of powers. So, I'm assuming you're catching on by now. This is going to be yes as well. It is a monomial. We can show out how many 2's that is. If you list it out to be 6 2's, and the next thing we're going to get into is have you simplify expressions like this. 2 squared times 2 to the fourth is going to be written as 2 to the sixth. And if you use your calculator on that or did multiplications in your head, you realize that's the number 64. Okay, after finishing problem 15, I'm going to cut the screencast off here, and we'll have a second part to finish up on this concept called product of powers. So you have to review 8-1 screencast number 2 to continue from here.